many study is focused on the ROS, not on the NO. So this is the first time to approach to ask the role of the NO in the response of the Chlamydomonas to highlight stress response. Okay, I use the highlight on at the intensity of the 1,600 micromole condition to treat Chlamydomonas, and we find that under highlight condition, the NO will produce at a very high level at the time advance. We use the DFA-FM diacetate to detect the NO, and you can see here, see my mouse here is the green fluorescence emit after highlight treatment. And you can use the CPTIO and NO scavenger to confirm whether this green fluorescence is emitted from the NO. And we can see here the CPTIO treatment will inhibit the green fluorescence from NO. So it's confirmed that under highlight condition, this green fluorescence emission is the NO production. So my this slide show you that the NO will produce under highlight condition in this ALD. Next, we would like to ask the question. We know that NO will be synthesized in the plant by NOS or NR. So we use the NO inhibitor NAME or MMNA, and also use the NR inhibitor Taunostate to inhibit the NO production. However, we found that this inhibitor cannot inhibit the NO production under highlight conditions, such as this one and this one and also this one. So our conclusion is that the highlight induced NO burst in the Chlamydomonas is independent on the NOS and NR. We don't know now yet whether it is synthesized and it come from. It need further investigation to approach his synthesis. Okay, in this slide, I would like to show you under highlight condition, this ALD will die under such extreme highlight condition, and we find that the cell growth significant decrease, and the viability also decrease, and we use the cytotoxic green dye to detect the cell death, and we find the cell death increase significantly, and that means the cell cannot grow under highlight condition. However, if we use the CPTIO to scavenger NO, and we can see the highlight induced cell death will be inhibited. This indicates that NO involved in the highlight induced cell death. Okay, the next question is I would like to know that autophagy is involved in the NO induced highlight cell death in the Chlamydomonas. So let me give you a brief background about the autophagy. Autophagy is a mechanism of the cell for removing unnecessary and dysfunctional component, and it allows orderly degradation and recycling of cellular component for the maintenance of the normal cell physiology. So the cell will alive and have a normal mechanism metabolism to survival under stress condition. However, autophagy also causes cell death depending on the character and the duration of the stress. If the stress duration is prolonged, the autophagy will very severe and cause the cell death. So my question is, the first question is whether autophagy can be induced by highlight stress. And the next question is whether autophagy is involved in highlight-induced cell death in this ALT. Okay, this slide show you that how to examine the role of the autophagy in the highlight-induced cell death and its physiological response. Generally, we to analyze the ATG gene because autophagy is regulated by the protein encoded by autophagy-related gene, ATG, like this one. Okay, therefore we check the expression of ATG gene under highlight condition, and we are very lucky. We find that under highlight condition, this ATG expression can be significantly induced under highlight condition, and this induction will be inhibited in the presence of the CPTIO. This is the NO scavenger, so it's confirmed that the highlight induced ATG expression is mediated by the increased NO production. And we also show the evidence to confirm the autophagy is occur under highlight condition in this when ALT. We know that ATGF is a marker for the autophagy in Chlamydomonas. So we use the Western blotting to test its expression under highlight, and we find that highlight can induce ATG8 and ATG-PE level, and this increase will be decreased by the CPTIO. This confirms that this induction will be caused by the NO. So the next experiment is we wondering under highlight condition, maybe some other interference from the highlight will affect the autophagy gene expression. So we apply the NO donor SNAP and the GSNO under normal light condition. That means 50 micromolar light intensity. It's a normal condition for the ALT growth, not a high light condition. And we find that the NO can induce the expression of ATG gene under the normal condition. and this induction can be inhibited by the CPTIO. So under normalized condition, only NO donor can induce the ATG gene expression, not under the highlight condition. Okay, we also found that the NO donor can induce ATG protein increase under normal light condition. This confirms that the NO can induce the autophagy under normal light, not necessarily under the highlight condition. So the NO only can induce the autophagy. So the above result, including the induction of the ATG gene expression and the increase in ATG protein level, evidence that NO is a factor for the induce of the autophagy under highlight condition in this green ALD. Okay, however, we find that the application of the NO donor in the concentration of 0.1 millimolarity under normalized condition only induce a transient cell death, but follow a full recovery. You can look here. After 24 hours, the cell recovery and goes well as compared to 3 hours. There is no cell can grow on 3-hour NO treatment, but however, they recover after 24 hours. This means that NO treatment under normalized condition is only induce a temporary cell death, cell damage, not a permanent cell damage like the high light condition. Okay, so we use the non-lethal middle highlight condition. ML means middle highlight condition. It is the 750 micromolar. Under this condition, the cell will not die, will keep alive. But we apply the NO donor at the 0.1 millimolar, and it causes cell death under midnight highlight condition. So it means that some factor occurring under middle highlight condition may interact with the NO for the induction of the cell death. Okay, so what is the factor or the factors? We find that middle highlight and the highlight illumination will induce ROS, especially H2O2 production. Like here, we use the DAB staining to detect the H2O2 production, and we find under 750 micromole and highlight 1,500 micromole intensity, the dark green DAB appear. This means that when high H2O2 production. Therefore, we propose maybe H2O2 is one of the factors in acting with NO for the induction of the cell death under highlight condition. So therefore, the NO donor will apply together with the H2O2 under normal light condition to check the interaction of the H2O2 with the NO for the induction of the cell death. And we find that after application of the NO donor in the presence of the H2O2, the ATG8 gene here increase, and the protein using the Western blotting detection, we also found the protein level will also increase, and using the image J to detect this density, we can find it's increased about 2-fold. Okay, and we also to check the cell death will be induced by the application of H2O2 with the NO. We found that if H2O2 applicate together with the NO will induce cell death under normalized condition. Here you can see here, SNAP and H2O2 cell cannot go well, and also the GSNO and H2O2 application, the cell also cannot go well as compared to the H2O2 only and the SNAP and the GSNO treatment only. So the above result indicate that the factor that mean H2O2 can interact with the NO for the induction of the cell death under highlight condition or under normal condition. And we also found that NO can induce significant RPO2 expression. What is RPO2? We found in the Chlamydomonas genomic data bank, there are two NADPH oxidase isoform, RPO1 and RPO2. And we find in response to the SNAP NO donor, RPO2 only show a slight decrease and follow a recovery after 3 hours. But however, RPO2 gene expression is highly induced after 1 hour of the SNAP treatment and then decrease to the normal level after 6 hours. So we hypothesize that maybe RPO2 can play some role in the regulation of the NO-induced autophagy under highlight condition. So we use the RPO2 mutant with the low gene expression to test whether RPO2 mediate the NO-induced autophagy. And we find that RPO2 mutant show very low ATG gene expression in response to NO. We use the SNAP to treat the RPO2 mutant. So this indicates that the RPO2 may be mediated the NO-induced autophagy activation in the Chlamydomonas. My model is like this cartoon. Highlight will induce NO highly production, and this NO accumulation under highlight will activate the RPO2 NADPH oxidase gene expression, and then this protein will induce the autophagy and then interact with the H2O2 to induce cell death. This is my model, but however, they need more study to identify and clarify their detailed mechanism, how they work. So in the final, my conclusion is the present study is the first time to demonstrate the interaction between NO and H2O2 for the activation of the autophagy cell death in the Chlamydomonas under highlight condition. And we use the RPO2 mutant. We found that RPO2 may be mediated the NO-induced autophagy in the Chlamydomonas. This is the first time to show this interaction. Finally, I would like to thank the government of the Taiwan to provide me the financial support to study this interaction of the NO and H2O2 in the regulation of the autophagy and the cell death in this model with ALT. Thank you. This is my talk.